Let's talk about something that happens millions of times a second, completely unseen. It's called SSH, the secure shell. Think of it as this invisible cryptographic handshake that lets us securely control computers all over the world. It's the secret language of the internet. And today, we're going to pull back the curtain and see exactly how it works. But first, let's start with the big problem. Think about it. The internet, at its core, is a public space. It's kind of like a giant open room. So when two computers want to talk, anyone could be listening in. So how in the world do you share a secret, like a password, if the very first thing you say could be intercepted by, well, anyone? And that is the core challenge. We call it the secret key problem. Back in the day, before SSH, tools like Telnet, they just set everything out in the open. Passwords, commands, you name it, all in plain text. That's literally like shouting your bank PIN across a busy coffee shop. It was a huge security nightmare, and something had to be done, fast.
All right, so one idea that came up was something called symmetric encryption. It's actually pretty simple. You've got one single secret key. You use that key to lock or, scramble up your message, and the person on the other end, they use the exact same key to unlock it. Just like a key to a safe, right? Same key locks it, same key opens it.
Now, this method has a huge pro and a huge con. The pro, it's super fast and efficient, great for sending lots of data. But, and this is a big but, we're right back where we started. How do you get that one secret key to the other person without someone stealing it? If you just send it over the internet, well, anyone could grab it, and your so-called secure conversation is totally busted before you've even said hello.
Okay, so clearly we need a smarter way to kick things off, and this is where things get really clever. Enter asymmetric encryption. Instead of just one key, we're going to use two, and there's this great analogy that makes it all click.
Imagine you have a digital mailbox. With asymmetric encryption, you get a pair of keys for it. First, there's your public key. This is basically the mail slot. You can give out the location of this mail slot to everyone. Shout it from the rooftops. Then you have your private key. This is the only physical key that can open that mailbox, and you guard that thing with your life. It is top secret.
So here's how that works in practice. Step 1. A server shares its public key with you. It's basically telling you, hey, here's my open mailbox. Step 2. Your computer takes a secret message, locks it up using that public key, and drops it right into the mail slot. And now for the magic part. Once that message is inside, the only thing that can open it is the server's private key. No one else can get in. And just like that, puzzle solved.
Okay, so let's recap. We've got symmetric encryption, which is super fast but has that key sharing problem, and we have asymmetric encryption, which solves the sharing problem but is a bit on the slow side. So what's the big, brilliant solution that SSH uses? Well, it's not about picking one. It's about using both of them to create the perfect, secure handshake. Yeah, this really breaks it down nicely. Think of symmetric as the sprinter. It's incredibly fast, perfect for the actual conversation. Asymmetric, on the other hand, is like a super secure armored truck. It's a little slower, but its one and only job is to deliver that secret key safely, and it does that flawlessly. And this is the aha moment. This is the SSH handshake in action. First, your computer and the server use that slower but super secure asymmetric mailbox system for just one thing, to safely create and share a brand new one-time use symmetric key. We call it the session key. And once that's done, they switch. From that point on, the entire conversation is encrypted with that lightning-fast session key. It is truly the best of both worlds.
So what this handshake really does is it builds what's often called a private encrypted tunnel. I love that description. Even though all your data is flying across the public internet, it's completely protected, sealed inside this tunnel that was created by that one initial super clever handshake. And here's the thing, this little two-step dance, using one type of encryption to set up another, it's not just some niche trick for SSH. It turns out this is one of the foundational ideas for, well, the entire secure internet.
So why should you care? Because you use this exact concept every single day. It's not just SSH. It's the secret behind HTTPS, that little lock icon in your browser when you're shopping or banking online. That's it. It's used for secure file transfers for deploying stuff to the cloud. Really, it's must-know information for anyone working in tech or cybersecurity. So next time you see that little lock icon or you fire up a terminal to connect to a server somewhere, just take a second to remember what's happening under the hood. The safety of our entire digital world pretty much starts with this one beautiful, elegant two-key handshake, all built to solve that simple, nagging problem. How do you whisper a secret when anyone could be listening?